All right, 3-4, dividing polynomials. So there are actually two ways to divide polynomials. You can use synthetic division or something called long division. So, excuse me, example 1 wants you to use long division. It works very much like long division that you learned in elementary school. But for the sake of time, we're going to stick to the easier, quicker method called synthetic division. So as you heard those words, easier, shorter, should be pretty quick today. Hopefully. All right. So the first example says use synthetic division to divide 3x cubed minus 5x plus 10 by x minus 1. So the first thing that we have to notice is that there's actually an x squared missing. So notice there's no x squared. If there had been an x squared, it would go in between there. So it would be 3x cubed plus 0x squared, because there is no x squared, minus 5x plus 10. Okay, that's important because you can never skip a term if you want this to work out right. So here's how our setup works. You want to do the opposite of -1. So the opposite of -1 is 1. And you do the opposite when there is a factor. So this particular problem has, x. So that's when I do the opposite. We'll look at some later that is not a factor, so we won't switch. But for this one, we definitely do the opposite. Then we line up the coefficients, so that's the numbers in front of the letters, across the top. Notice if there's a minus sign, I make it negative. If it was completely missing, I made it 0. Also a reminder that if it's just x, that it's the number 1. Okay. Next step. Bring the 3 all the way down. You're going to multiply the outsides and add the inside over and over until we get to the end. So what does that look like? Here we go. Multiply 3 by 1. And we get 3. We write that answer in the diagonal. Add straight down. 0 plus 3 is 3. Repeat. This time we're multiplying with the second 3 by 1. It's still 3, so we write our answer in the diagonal there. Add straight down. So -5 plus 3 is -2. Repeat one last time. This time -2 times 1 is -2. Add straight down is 8. Okay, that's all the math. Now we're ready to write the answer. Okay. If we think about x cubed being divided by x, that leaves us with x squared. It's always 1 less than what it was before. So this was a 3, it's now going to be a 2. So 3x squared plus 3x minus 2. You may recall that this is called a remainder. You may recall the word remainder from elementary school. Same idea. So to write that answer, we're going to say plus x over what we divided by originally, which is x minus 1. So there we have it. We divided. Now, this one had a remainder. If you think back to factoring, they worked out nicely, right? So that means if I divided, I should get a remainder of 0. Just like if I divide 13 by 4, I get a remainder of 1. But if I divide 12 by 4, I get a remainder of 0. Okay? Same idea there. So let's keep working. Don't stop. Don't be like, whoa, this is crazy. Because it is easy once you figure out the steps. And the only way to get those steps down is to stay with me, try it again, write it down. Okay, so let's try it again. This time we're going to do something called the remainder theorem. So x cubed plus 8x squared plus 12x plus 5 divided by x plus 2. That means that, so let's take care of that first. We're dividing that right there. That means on the outside we're going to put a -2 because remember we always make it the opposite. Then we do 1, 8, 12, and 5. First step is to bring the first number all the way down to the bottom. Multiply the outside, so -2 times 1 is -2. Add straight down. Those arrows are not necessary if you know what you're doing, but I write the arrows to kind of help you see where I'm going here. 8 plus -2, so that's the same thing as 8 minus 2 is 6. Repeat. 6 times -2 is -12. 12 minus 12 is 0. 0 times -2 is 0. And 5 plus 0 is 5. Okay, I don't even have to write that out yet because I just, we're doing something called the remainder. So we only care about the remainder. So pause there. For our next part, we're going to do f of -2. That means for our function x cubed plus 8x squared plus 12x plus 5, everywhere that there's an x, we're going to put -2. So in this case, there were 3 different x's, so I replaced those with -2. I'm going to take the quick and easy way, meaning I'm going to go to Desmos here. And I'm going to just type the whole thing out. So -2 parentheses cubed. Uh-oh. Oh, I forgot to square this one. And I forgot a 2 there. Okay, shoo. Typing for accuracy is important. So -2 cubed plus 8 times -2 squared plus 12 times -2 plus 5 equals 5, according to my calculator. I could also do the mental math if I wanted, and I should also get 5. So notice that that's the same answer we got with the remainder. So if I didn't have a calculator present, I would have had to do all of this mental math. So I would have had to know what -2 cubed was. I'd have to then do 2 squared times 8, add that. So like a whole lot of stuff, right? But I didn't really do any extraneous math for my brain when I did synthetic division. So the remainder theorem just says whatever the remainder is actually what it would be if I plugged in the number that I was dividing by there. So like if I plugged in -2, I'd get the same thing as if I divided by -2. So that's pretty cool. All right. What if we look at a technology company's function there, so that R of X function, and it models an expected annual revenue in thousands of dollars for a new product, where X is product of years to release. We could use the remainder theorem to estimate the revenue in year 5. Year 5, we have -1, 12, 6, and 80. Bring it all the way down, multiply to get -5, add to get 7, multiply to get 35, add to get 41. This may still require a calculator. Uh-oh, why do I keep doing that? Sorry, guys. 41 times 5 is 205. Plus 80 is 285. Okay. So the revenue in year 5 is $285,000 because it's in thousands. So hopefully by now you're thinking, okay, this synthetic division is not too bad. It's weird. Never seen anything like it, but it's not too bad. Okay. So last example here. We're going to determine whether this is a factor or not. So this is where it is a factor if the remainder is 0. So remember, this is a factor. It has x, so I have to put the opposite number on the outside. I'm going to line up my numbers. 1, -10, 28, -16. And I'm going to do some math. So 1 times 4 is 4. Add straight down to get -6. -6 times 4 is -24. Add straight down, 28 minus 24 is 4. 4 times 4 is 16. -16 plus 16 is 0. Okay, so remainder of 0, yes. X minus 4 is a factor. So here's what that means. So we're going to extend that thinking just a little bit. So this final answer is 1x squared minus 6x plus 4. No remainder, so I don't have to worry about that part. So it holds true that since it divided evenly, if I multiplied the two back together, I should get this as my answer, which would be true. So if you want to pause and test that, you are more than welcome to. But if I can take the answer and multiply by what I divided by and get that back. So let's do that in real numbers. If I divided 12 by 4, I get 3, right? That means that 4 times 3 equals 12. Same as here. If I divide x cubed minus 10x squared plus 28x minus 16 by x minus 4 and got x squared minus 6x plus 4 is my answer, I can multiply that by the x minus 4 to get x cubed minus 10x squared plus 28x minus 16 back. Okay? All right, last one. Let's see if this one is a factor. This one's a little longer. It's x to the 4th, so I got an extra number there. 2, 9, -2, 6, -40. All right, bring that first number all the way down. Multiply to get -10. Add straight down to get -1. Multiply again. -5 times -1 is 5. -2 plus 5 is 3. 3 times -5 is -15. 6 minus 15 is -9. -9 times -5 is positive 45. -40 plus 45 is 5. So no, x plus 5 is not a factor. All right, you have completed the notes for synthetic division. Go ahead and try your practice target.